In this section, we will discuss more operations with arrays and matrices. So let us first consider the basic arithmetic operations. Arithmetic operations with arrays. Okay. Now one can easily perform any arithmetic operations with arrays by using arithmetic operators that we have already discussed. Like for addition, we use plus symbol. For subtraction, we use minus symbol and also. So those kind of arithmetic operators that we can use directly in when you are doing arithmetic operations with arrays. Also, there is another option which is by using Numpy functions. So for all these arithmetic operations, we have corresponding functions defined in Numpy. So one can also use the Numpy functions to perform these arithmetic operations. So in this section, we have included all the arithmetic operators used to perform different operations with arrays or matrices like addition, subtraction, multiplication, etc. So first we'll discuss about array addition. Let's consider array addition. So for array addition, first we have to import the Numpy module because we are considering all these arithmetic operations and arrays matrices in Numpy module, right? So we have to import Numpy module first. So just I will import Numpy as np. Now then we have to give some array in order to add or do the addition operation. So first we'll consider array addition. Okay. So let us consider an array A which is equal to np dot. I'm just creating that array by using this array command np dot array function. So here we'll be having some elements 1, 2, 3. These are array elements, and I'm using list. This list 1, 2, 3 to create that particular array. Okay. So you can see that 1, 2, 3 are the elements that we have included in this array A. Now we have to define one more array. Let's say B equal to some np dot array. So I'm creating again one more array with list. And this time I will use some different values 4, 5, 6. Here also I'm using list to use to create that particular array. So here we have two arrays A and B. Now we have to add these two arrays. So for that we can directly use the operators, arithmetic operators. So if I write A plus B, I will directly get the answer as array. So that will give you another array with that particular addition. So in here, you can see here we have the addition of elements of the same position in this matrix. We can say that the elements with the same index value they are added to form this resultant matrix or resultant array. It is not matrix, it is one dimensional. So in this case, this one is added with this 4, and that will give you that the result 5. Similarly, this 2 will be added with this 5 and you'll get 7, and so on. So each of these elements are added up. Okay, and that will give you the resultant array. So that is performed by using this particular plus operator, that is for addition. And if you consider another method, that is as I discussed earlier, by using Numpy functions. So for that addition, we have a function which is nothing but np dot add. You can use add function, and then you can give which are the arrays that you have to add a and b. So a comma b I have to give, and then if I press enter, I will get same result. So here I am using this numpy function add to perform this addition operation. Okay, and here I am using addition operator plus. So this is the resultant array 5 7 with elements 5 7 9. Now, in the same way, you can go for array subtraction. So I am just using the same array for subtraction also. So I will be discussing here array subtraction. Okay, in this case, I will just use the same elements, same array, and I will just write a minus b. So here also I am using just this minus operator. Okay, to do this arithmetic operation, that is nothing but subtraction. So here subtraction will get the values as minus 3, minus 3, minus 3, because we are just taking the difference between these two. So 1 minus 4, that will give you minus 3. 2 minus 5, that also will give you minus 3. 3 minus 6, that also will give you minus 6. So each of these elements will be subtracted. Okay. So when you consider the function corresponding to the subtraction operation in the case of NumPy, then we can use np dot. So in here, I am just using the function instead of directly using this operator. So I will be just going through this function subtract. I just subtract subtract. So and I have to give the array names. Okay, so np that I have to give as the arrays, and then I will get same result. So here I just used this subtract function from NumPy module to subtract the elements in that particular arrays, and that will result you another array with the same dimension. Okay, and in the same way we can go for multiplication, division, modulo operator, all those things. I will just do all those operations here. So let me do the multiplication now. So a star b, I multiplied with b. So that will give me the array with 4 elements, 4, 10, and 18. That you can directly get from here. 1 into 4 is 4, 2 into 5 is 10, and 3 into 6 is 18. So all those elements are multiplied. And we'll get an array which is equivalent to this A into B. That is how the multiplication work with the multiplication operator. Now we will go with the function, NumPy function for multiplication. So that is nothing but np dot multiply. Multiply. So then I have to specify the arrays a comma b. If I press enter, then I will get same result. So this in this case I have used this np dot multiply function to perform the multiplication operation. And then we have a division. For division, we just use the operator first, a by b, and that will give me 0.25, 0.4, and 0.5. That is just the division of 1 by 4, 2 by 5, 3 by 6. Now, if I use the NumPy function for division, then I can use np dot divide. Let me see that. Maybe it's only I. Let me see that. So divide. So here I have to specify the arrays A, B, and I will get the same result. So here I have used np.divide as the function, NumPy function for division. And we can also go for modulo operation with this NumPy. So I will just use the same arrays, and I will just here I will just go for B mod A. So I'm just using modulo operator. You know this modulo operator will give you the remainder, okay, remainder of a particular division. So if I do B modulus A, modulus operator A, then that will give me just the remainder of if I'm dividing this 4 with 1, 4 by 1, if some remainder is there, then it will give me the answer that particular for that particular index or position. And then it will take the division of 5 with 2, 5 by 2. If there is some remainder is present, then it will give me that value and so on. So B, I'm just here I'm dividing B with A. Okay. So it will be like B by A, and the remainder will be the result of B mod A. So modulus operator. So this, if I calculate that, then I can get another array, which is nothing but the remainder when you are doing this B by A. So we can get the elements 0, 1, and 0. So this, when you divide 4 with 1, then there is no remainder. When you are dividing 5 with 2, there is remainder 1. And then we are when you are dividing 6 with 3, then you will be getting no remainder, so it will be 0. So the same that we can perform by using the numpy function. For this, we will use np.mode. For modulo operator, we use mode, and then we will just write b comma a. You can also perform a comma b, but that will definitely give some values. But here we are considering the most easiest way. So array 0 comma 1 comma 0. So that is same result. So here we have used this mode function, np.mode function, to perform this modulo operation. Now we'll go for some interesting operations. So when you are considering the arrays, there are some different products that we have to consider apart from the conventional multiplication. So we have basically the dot and cross products, and these dot and cross products are entirely different from the conventional array multiplication. So in conventional array multiplication, we are just multiplying each and every elements by with the same indices or same positions. But in this case, we are not just multiplying the elements as the conventional way. These multiplications are performed when you are having this with the vectors, okay, which can be a two-dimensional array. So if you're considering a vector, then you can represent it as a one-dimensional array, right? So in that cases, we can take dot and cross products of those vectors, as well as if you consider two-dimensional array, then you can consider it as a dot product or cross product with the matrices. Okay, so all those things that we can consider. So here we will consider the dot and cross products. So as I said, it is not a conventional product of those elements of the individual arrays, but it is having some difference when you're considering the result. So I will just give an example for that. So we will just this dot and cross products. So let us consider an array. We'll just put an array A equal to np dot array. So I'm just using tuple here, 2 comma 3. Define this array. I'm just using tuple. That is this bracket you can see here. And then I will define one more array. It's b equal to np dot, or I can just copy this. So I will just replace this 2 and 3 with 1 and 2. These two are one-dimensional arrays. First one is having elements 2 and 3, and second one is having element 1 and 2. Now, if you take the dot and cross product of these two arrays, so let us consider. If you take the conventional multiplication, what you will get? Let us consider that first. So A star B, if you consider, then you will be getting 2 comma 6. So it is just multiplying individual elements with the same indices positional value. And then if you consider the other products, dot and cross product in this case, for example, so for that we have to use np dot dot. It is a function, numpy function for the dot product. So this dot product operations or that particular program is saved in numpy module. So we can directly use that particular program or that section from numpy module. We can load that or we can import that by import numpy as np, and then whatever saved in that numpy module, that we can access directly by using this np dot method. Okay, so I'm just using this dot function from that numpy module. That's why I'm writing np dot dot. So dot product I have to calculate, so I will be using np dot dot, and which are the arrays a and b, right? So I will just give a comma b here, so that I will be getting the dot product of this a and b. So that is nothing but 8. Okay. So in this case, it is not a conventional multiplication of the elements, but it is rather a different kind of multiplication in this particular case. So we will be getting the multiplication like this 2 is multiplied with this 1. Okay, so we'll get 2, and then this 3 is multiplied with this 2. So we'll get 6, and those values are added to each other. So 2 into 1 plus 3 into 2, that will be 8. So that is what happened here. So it's just like a matrix multiplication that we will discuss here. Okay. So when you are considering that as a two-dimensional array, then we can consider it as a matrix, and it will be, we can understand that more easily. So here I will just put another array with which is two-dimensional. So np dot array, and I will just so in this case I need basically 2 rows, so 2 columns and 2 rows, because we need two-dimensional. So 2 comma 3 comma 3 comma 5. Let's cancel that. I have to close all those brackets. So this is my A, and I will just define another array, np dot array. I'm just creating that array. So then I have I can use 1 comma 2. You can give any elements. Okay, so 1 comma 2. I'm just giving some elements here. 1 comma 2 comma 5 comma some minus 1. Okay, so this is my second array. So I have defined two-dimensional arrays. First one is A and second one is B. Now I just want to take the dot product of these two. So this is two-dimensional array, and then we can represent that as a matrix, right? Because two-dimensional arrays are nothing but matrices. So here, if I take the dot product, then I can just put np dot dot of A and B. So A comma B. So I have to take the dot product of these two arrays. Then if I press enter, then I will be getting a new array with these elements. So here we can see that the dot product is not same as that of a conventional multiplication. So here I'm just multiplying these 2 and these 3 with so this will be my first row, right? So this is my first row. This is my second row of that array A, and this is my first row of array B, second row of array B. So this first row will be multiplied. So 2 comma 3. So that will be multiplied with 1 and 5, right? So if you consider matrix multiplication, this 2, 3 will be multiplied with this 1 and 5. I hope you know this matrix multiplication. So if you want to get that more clearly, so we'll just press that A. This is my B, and NP dot. Just take that dot product again. I just showing that elements how that is multiplied. So you have, this is my first array 2 comma 3 of array A. Sorry, first row of array A, and this is my first row of array B. And if you want to multiply these two matrices or these two arrays of 2 dimensional, then I will just multiply this row with this column 1 and 5. Here, this 1 and 5. So 2, it will be multiplied like 2 into 1, that is 2, plus 3 into 5. So that is 15. So 15 plus 2, that is 17. That is the first element. And for second element, that is this one, for this one, I have to multiply the same 2 with the second column of the P. So 2 into 2, 4, and then 3 into minus 1 is minus 3. So adding those two, 4 minus 3, that will give me 1. Okay, so similarly, we can consider all these elements. We will get all those elements if you consider those matrix multiplication. So that is what we have, we performed here by using this np dot function. So we can also do the cross product also in for vectors and matrices if we consider. So here we can use np dot cross as the function to perform the cross product operation. So a comma b, we'll be getting an array like this 1 comma minus 28. That is the cross product result of that cross product of these two arrays and b. So we can perform these products or this kind of operations also by using these arrays. So if you are doing that with a two-dimensional array, then it is nothing but a matrix multiplication with that dot product cross product. So that can also be performed. Now, instead of doing like this, we can directly take it as a matrix itself. Okay, so in that case, if you are defining that as a matrix, for example, if I am putting it as matrix itself, so we have a different class in this Numpy module, which is matrix class. So we can directly give or create matrix in this particular Numpy module. So for that, I will just replace this array with matrix. One can also use this matrix class. Okay, this also possible. So this here I am just defining or creating that matrix A. Okay, similarly, I can go for matrix B. So instead of considering the two-dimensional array, I'm just defining this as a matrix itself. So that is also possible in by using this Numpy module. So this A equal to np dot matrix of these elements, which is nothing but the matrix A, and here we are having matrix B. And if you take the product of these two now directly by using the multiplication operator, then it will do the matrix multiplication. Instead of multiplying the elements, it will directly do the matrix multiplication because we have defined this A and B as matrices. So if you are using it as an array, then this multiplication A star B will be performing like the multiplication of the elements. But once you have defined these two as matrices, then if you are taking A star B, then it will be directly taking as matrix multiplication. So here you will be getting the result of the dot product. Okay, so I will just write that. You can see that the elements are 17, 1, 28, and 1. That you have also received. You have got the same result when you have taken the dot product of those matrices by using this two-dimensional array. Okay, so basically this A star B will perform the same operation of dot product or matrix multiplication once you have defined that as a matrix. Okay, instead of an array. So you don't have to give this np dot function if you are defining that particular A as a matrix itself instead of a two-dimensional array. If you are using that two-dimensional array method, then you have to give np dot dot for taking the dot product or matrix multiplication. Okay, so this is also possible. And now we will go for array saving. How we can save a particular array in a particular uh, name. So let's consider the same. Okay, I will just do it again. So A equal to np dot. Let us consider a one-dimensional array with the list of values 1, 2, 3, 4, 5. So this is my array A. Now, if I want to save this particular array in a particular name, okay, so we can do this by different method. So in NumPy saving, we can also we can directly use save function to store or save the array with the npy extension. So if you are saving that particular array by in NumPy by using save function, then it will be saved as a .npy extension. Okay. So when you're saving a picture in your system, then you will be saving it as a .jpg, or you are using .png or something like that extension you are using for figures. Here we will be using, if you are using the save function to save or store a particular array in a memory location, then the extension of that particular array will be .npy. Okay, so for npy extension, with npy extension, we can use save function. So if you want to get the syntax of that particular function, then we can write it here. So this is the syntax for save function. So syntax will be like numpy dot save, and then you have to specify the file name that in which that file has to be saved, or that particular array has to be saved. That you have to specify. That is the file name. Then you have to give the array also, but which array we have to save in that particular file that you have to specify. And then there are some more thing that we have to specify here. That is not necessary. That by default it will take as a true, but for sake of your syntax, we can do it here. So we can consider the pickling. So this allow pickle that you have to give as true. That is nothing but allow this saving object arrays using Python pickles. Okay, so that is if you are not going to give that, it will take it as true by default. And we also have fix imports. So these things are not necessary, but by default it will take as true. Okay, so now this is the syntax, and now we'll go to for an example. So I'm just using this array A, and I want to save that particular array. So I will be using np.save to save that array or store that array into a memory location. So once you have this, if you are using this np.save function, then you have to specify first. You have to specify the file name. So let me say that is numpy file. I'm just providing some file name. Okay, so that has to be string. So here will be like this. So you don't have to specify the .npy extension here. It will automatically take it as .npy extension, which means that numpy file.npy. That is the total file name with extension. Okay, so this is my file name, or and I will just give which array I have to save. That I also have to give. So I will just put A here. That is my array name, and you can give also allow pickle equal to all those things. That is not necessary. So I will just use these two these two are compulsory. So this is file name and array. Which array I have to save it as with that numpy file name. Okay, so if I press enter, so now my file is saved in that particular name with the .npy extension. Now, if I want to take that particular file, so I mean that is the restoring of that particular file, restoring of that particular array. So this is just a saving and restoring of that particular array. So if you want to restore that, then I can use the load function. So I will be using another array name b equal to np dot. In this case, I have to use this load function. Load function is used to np dot load function is used to load or restore a particular file from memory location. So I will be just providing that file name. That is nothing but numpy file, and here I have to specify the extension npy, and then I will just close this bracket and load. And if I print that b, I will be getting the elements of that particular array that we have saved as numpy file .npy. So here I'm just loading, or I'm just restoring that particular file, that particular array with the name b. Okay, so in this way you can save a particular array. Also, you can retrieve or you can restore that particular array elements. But here we are using np.save function as well as np.load function to save as well as retrieve or restore that particular array. You can also save a particular array in a different extension. For example, if you want to save an array in text as a text file, then you can just use np.save text, that is save txt. So in this case, this particular, oh, I think missed one key here, save txt. And in this case, you just give the extension as txt. So I will just do this, and I will just put here txt extension, comma, I have to save a as txt. So it is just saving that particular array as a text file. Okay, so this can be used, and in this case also I can give b equal to np. So here I will be considering load, and instead of simple load, I have to give txt also. So load txt. So here save txt, here load txt to restore that particular. And here I have to change the extension into txt. Okay. And also you can give the data type and all those things also here. The type you can specify the type equal to some integer values. Okay, so that elements saved in that particular array will be converted into that particular data type. That particular data type. In here we are considering integer type. Okay, so here we will be loading that array which is saved as a txt or text file with this name b. So I will be just simple, and if I want to get print, if I print that b, we will get all those elements 1, 2, 3, 4, 5 as integers. So this is how we can save a file or array in txt format as a text file. Okay. And if you are having multiple arrays, then you can save it as a zip file. For that, we can use save z, or you can directly consider as saves. So np dot saves or save z, and what are the arrays that you have to. So first we have to specify the name. So AB is my name, and here I will be using npz as my extension. Npz stands for zip file. So I will be using this as so all these are in numpy modulo. All these things we are doing in Numpy module. So .npz in Numpy module, which is corresponding to the zip option. So npz is for zip file, making that particular array as a zip file. And this particular function we will use when you want to save more than one array into a particular folder, for example, for a particular location as a zip file. So it will contain number of arrays. A particular location contains number of arrays. That file name, includes multiple arrays. So here I am considering ab.npz. So here we are going to save two different arrays into that particular zip file. So ab.npz I am using. So ab.npz. I will just give some x equal to a and y equal to b. I'm just giving those arrays a and b with some different names x and y. So this is nothing but saving two arrays a and b in .npz extension as a text file as x and y. Okay, and I will just press enter here, so that will be saved as a zip file. And if I want to get that particular file, I can give c equal to some other name I'm giving. So np dot, you can give any name here. I'm just giving c. Okay, so don't confuse with this c. So I will just give np dot, and in this case I have to load that zip file, right? So in that case I can simply give load, and what I have to load, I have to load ab. Ab is my zip file name. ab.npz zip file I have to load. So this is nothing but restoring the arrays as zip file. Now I will just press enter. So I have loaded or restored array as C. Okay. So that particular C contains more number of arrays. In this case, we are having two arrays in this particular name C. So I will consider C of X. So that will give me the first array, because I have saved it as X. I have given X equal to it. So that will give me the first array in C. So if I press enter, then I will be getting 1, 2, 3, 4, 5. That is my array A. You can see here. I think I didn't change the B, so in both cases we'll be getting same elements. But anyway, so if you are giving Y instead of X, you will be getting the second array. Unfortunately, we have saved that as with same elements, so we will not be able to distinguish that. But you can see that. So here I have given B as 1, 2, 3, 4, 5, and A also with same elements. So we'll be getting same elements. You can see here that my A is also same. Anyway, so see, this is how we'll save the array in as a zip file, and how we can load that zip file, and from that zip file how we can load individual arrays saved in that particular zip file. Okay, so that all about the saving and restoring of arrays. This is not limited. There are many different methods in all these sections. I'm just giving you some of the examples. If you consider those operations, array operations, arithmetic operations, we have different operations or methods available by using this Numpy module. So I'm giving you some of the important functions or important methods. So you can check for more details or more methods available in each of these sections. Now we'll go to the linear algebra section in Numpy, and by using this linear algebra module, we can get the determinant of a matrix, we can get the rank of a matrix, eigenvalues. All those things can be calculated by using this linear algebra, but we will be considering two examples here. So here we will consider linear algebra module in Numpy. So we'll be writing linear algebra module in Numpy. So here, as I said, this linear algebra in NumPy provides various methods to apply linear algebra or NumPy arrays. So by using linear algebra module, one can find the rank of a matrix, the determinant of a matrix, eigenvalues, all such kind of inverse of a matrix, all those kind of operations can be performed by using this linear algebra module. It can also be used to solve linear equations. That also we'll consider here. So first we'll consider the inverse of a matrix. Inverse of matrix by using this linear algebra module. So for that we will use inverse function, that is inv function, np dot inv in NumPy linear algebra module. To calculate the inverse of a matrix. So the inverse of any matrix is defined in such a way that if it is multiplied by the original matrix, it results in identity matrix, right? So if you are having A as your matrix and if you are calculating A inverse, when you take product of A inverse with A, then it will give you identity matrix I. Okay? So that is how we'll define A inverse. If it is not the inverse of that particular matrix, then that will not result in a identity matrix. If you take the product of that A inverse with A, if it is not giving you the identity matrix with elements 1, all the elements as 1, then that is not the inverse of that particular matrix, right? Now we will consider the inverse of a matrix by using NumPy.linear algebra method. So here I will just use this linear algebra module in NumPy. So let us consider, let us create a array. So I will just consider a two-dimensional array. So here I will be using list to represent the elements. Sorry, 1 comma 2 comma. I will use just 1 comma 4 as the other elements. So this is my array. Okay. Now if I want to calculate the inverse of this particular matrix, so this is a two-dimensional array. So we can just consider it as a two-dimensional matrix. It is like 2 by 2 matrix. So we can take the inverse of this particular matrix, and I will store that value into B. So np dot for inverse, as I said, np dot inverse inv is the function to calculate the inverse of a matrix or two-dimensional array. So if you consider the np dot inverse of A, then that will give me the inverse of the matrix A here. So I will just press enter. Oh, sorry, I have to use the inverse function from linear algebra module. So I have to give b equal to np, which is in NumPy. So I have to give np dot, because linear algebra module is saved in np, that is NumPy. And then after that, I have to specify which function I have to do, which module I have to use. So I have to use linear algebra module. And then I have to give inverse dot inverse. So in NumPy, I'm using this linear algebra module, and in that module, I'm using this function inverse. Okay, so np dot linear algebra dot inverse. So an inverse of A. I have to specify that particular matrix. So that is my B. Okay, so how we know that whether this B is inverse of A or not? For that, we have to take the dot product of A and B. And if it is resulting in identity matrix, then B is inverse of A. Right now, I will just print A here. Print A. And it's the end there. So print A. So print A is this. My matrix A is this, and then I will print B. So my matrix B is this. So if I take dot product of these two matrices A and B, so for that I will use np dot dot and I will just give the matrices A and B, and I have saved all those values, elements values into that dot product values into C. And if I take print C, so if B is inverse of A, then I will be getting the product of these two as an identity matrix. A and B, product of A and B should be an identity matrix. Right? So print C, if I give, then I will be getting this identity matrix. This identity matrix, you can see the diagonal elements has to be one. Okay, diagonal elements has to be one. That's right. So this is uh, how we can prove that the V matrix that we have calculated by using this linear algebra dot inverse function is the inverse of A. Okay, so this is how we can calculate inverse of a matrix by using this linear algebra module. In the same way, we can also calculate the determinant of a matrix. So this determinant is used in different sections, especially in uh, physics. We can use this particular technique, determinant of a matrix, to specify different physical properties. Okay, so and you know this, if the determinant of matrix is zero, then it is called as a singular matrix. If it is not zero, then it is non-singular matrix, and so on. So there are many different properties that we can get by calculating the determinant of a matrix. And also we can use to this determinant method to solve different equations. We can also calculate eigenvalues if you are considering uh, that mathematical part. Okay, so but we are not going to discuss all those things. I'm just telling you, by using this determinant of a matrix, we can do different operations. We can have we can specify different properties. So I will be just calculating the determinant of a matrix by using this linear algebra module in Numpy. So for that, I will be just considering, let's consider the NP dot linear algebra. Uh, so this determinant is also in that module linear algebra. So I have to give linear algebra dot in that particular module. I have to use determinant. So the det is the function for determinant, and determinant of A I have to calculate, for example. When I press enter, so I will be getting 2. So this is the determinant value of that particular matrix A. This is my matrix A. So that you can directly get, if you consider this as a 2 by 2 matrix, then the determinant of this particular matrix will be 1 into 4, right, minus 2 into 1. So that will give me 4 minus 2, that is 2. So you can calculate that determinant of matrix by using this particular function np dot linear algebra dot det. So by using this det function, we can calculate the determinant. And this function is defined in this particular module, linear algebra, and that particular module is inside this numpy module. So that's why we are giving np dot linear algebra dot this one. So this is how we can calculate the determinant of a matrix. And now we'll discuss how we can solve simultaneous equations by using this NumPy module. So here I will just consider two different equations to solve, and we have to find out what are the unknowns. Okay. So all the equations, let us consider it as ax equal to b, and this first A will be representing the coefficient matrix, which means that if you're having n number of equations, we'll be having different coefficients. For example, if you consider here, I will be considering x plus, let's say 2y, that is equal to 1. And again, then we'll be considering 3x, 3x plus 5y equal to 2. So these are two equations that we will consider here. So we need to solve these two equations. So what are the unknowns? Unknowns are x and y. X is unknown, y is also unknown. So if you consider these two equations, we have coefficients here. For x, we have coefficient as 1 here. Symbol x means 1x, right? And we have here we have coefficient as 2 for y. And here we have coefficient as 3 for x, coefficient 5 for y. So if you consider those values, then we can have a matrix with elements 1, with elements 1, 2 in first row, and 3, 5 in second row. So we have 2 by 2 matrix with elements 1, 2, 3, 5. That is my coefficient matrix. And then we have two unknowns, x and y. These two are my unknowns. So they can be represented as a column matrix, x and y, with the two rows and one single column. And then in the last, we have these constant values. So these are constant matrix, which is again 2 rows and one single column matrix. So 1 and 2 with elements 1 and 2. So if you use these two equations, and we can solve this particular equation. So this A here, this A is representing those coefficient matrix. This X representing a single column matrix, 2 rows, single column. So in that case, we will be having X and Y as our unknowns. So X and Y as our column matrix. And then we have this B as your constant values, which is again a column matrix with values 1 and 2. Okay, so now if you solve these two equations, so I will be having, in this case, I will be having A as the first matrix. So I will just give you, so what will be my A in this case? So array, so A will be array P dot array. You don't have to specify these things to solve this equation, but I'm just giving you a hint. So okay, in this case we have to give as an array itself, because we have to solve for x and y. Okay, so what is A? So I'm just considering this particular equation. Okay, so Ax equal to B. So A is coefficient matrix, X is unknowns, X is the matrix that is representing unknown, B is my constant matrix, which is these values. So A will be np dot array, and for that array I will be having elements. So as I said, this is a coefficient matrix. A is coefficient matrix. So my first coefficient is 1 for x. I'll be just writing that 1. Then second for y is 2. So I'll be writing 2 here. And that is for first equation. Then I have the second equation where we have the 3 as my first coefficient for x and 5 as the second coefficient for y. And then I close these brackets. This is my first matrix A. Then I have capital X as the second matrix, that is unknown matrix. So that is nothing but the unknown values x and y. So np dot array. So here these values we don't know, so we don't have to specify that. We have to solve for x. Okay. Then we have the matrix B. So np, that is known to us. Values are known to us. So array, and then I will be. So this is just a column matrix, right? So I will be giving the values, those constant values, 1, 2, and closing that bracket. So this is my B. So this is my A, that is my coefficient matrix 1, 2, 3, 5. So these are the coefficient matrix, and then elements of this coefficient matrix, and then this is the constant matrix, that is nothing but the values, this 1 and 2, whatever, and that is resultant of these equations. So here B equal to np dot array 1 comma 2. So these are the matrices. If you want to see those matrices, then it will be like this. In A, then in B will be like this. So this is a 2 by 2 matrix, and this will be a 1 by this is having, actually this is representing 2 rows and single column. And now if you consider the solution for the x, I'm just using capital X. So I don't know what are the values for x and y. So I will be using it as an x matrix, capital X matrix, column matrix. So x will be equal to, now I have to solve this particular equation. So I will be using that np dot linear algebra. So inside that linear algebra, I can directly use solve function to solve any linear simultaneous equation. So I will be solving for a comma b. I have to just give the coefficient matrix as well as the values, the constant matrix b. Okay, so actually what we are doing here, we are considering this from these two equations, x plus 2y equal to 1 and 3x plus 5y equal to 2. We are constructing this equation x equal to b. Now I know what is a, I know what is b. If I multiply a inverse here in this side of this equation, then I will be getting identity matrix multiplied with this a capital X. So a inverse a will be I. So that is multiplied with its capital X. So that will be nothing but x itself. And then if I multiply a inverse on the other side, then we'll be getting a inverse into b. So whatever that multiplication result, that will be my x. So a inverse into b will be x. So in that way, we can solve for x. So that is what we are doing here. Okay, so linear algebra or solve will be doing or multiplying a inverse with this b matrix, and that will give me the result of for that x, capital X, and that x contains elements x, small x, and y. So that matrix will be x and y as the elements. So for that, we have to solve. So if I write print capital X, so I will be getting -1 and 1. So these are the values for x and y. This is how we'll solve the simultaneous equation by using NumPy. And if you want to check whether this result is correct or not, then I can just give like check equal to. Now I will just consider x of 0, that is the first element of this particular matrix x, that is nothing but -1. And this has to be multiplied with okay, this has to be multiplied with the coefficient. So here we are having coefficient as 1, right? So I will be just multiplying here this x of 0 with 1 plus then I have a 2y here, right? This is 1x. Okay. So I can write it in the same order. I will be writing 1x here, and then we have, so this -1 is representing for x and 1 is representing y, right? It's like a column matrix. So x equal to -1, y equal to 1. So for x, I am just putting x of 0. That is the first element of this capital X matrix. And x of 1 will be y. Okay. So I will be putting 2 times y here. So 2 times x of 1. So that is this equation. And so this x, so I am here, I will be considering it as 1x plus 2y. That is what I have written here, 1x plus 2y. And that will give me 1. That has to give me 1. If this x of 0 is equal to -1 and x of 1 equal, that is nothing but y equal to 1. If these two are equal, if this is right, then it will give, if I calculate this value, 1x plus 2y, that should give me 1 as answer, right? So if I print that check, I should get 1. It is almost 1, 0.99. So that works, which means that this result is correct. -1 and 1 for x and y is correct. Then only it will give me the result of this 1x plus 2y, that is nothing but this, equal to 1. So this is how we can solve the simultaneous equation by using linear algebra method or linear algebra module in NumPy module. So you can see we can use this solve function to solve any linear simultaneous equations. Okay, so we'll stop here and we'll do some different operations in the next class.